In this video, we're going to be determining the number of protons, neutrons, and electrons in each of the following species. So let's begin with oxygen. So let's give our numbers 8 and 16 here. So first, we need to determine the number of protons. Well, the number of protons is unique to every element, and it has to do with its atomic number, which we can see over here on our periodic table is 8. So 8 is going to be equal to our number of protons because that is the atomic number of oxygen. Next, we need to determine the number of neutrons. So what we'll do for that is we will take our atomic weight, which is this top number, we'll subtract it from our atomic number, and we'll end up with 16 minus 8, which is equal to 8. So in this case, we have 8 neutrons. Finally, we need to do electrons. Now, electrons is going to be based off of the charge of our element and the number of protons. In this case, we have no charge, so we consider neutral. So that means our electrons equals our protons because our protons are positively charged and our electrons are negatively charged. And if we want a neutral element, they have to be matching to one another so that they cancel out. So we have 8 electrons in this case. Let's move on to another example. Let's stick with oxygen, atomic number of 8. Let's say that it has 22 for an atomic weight. So again, our protons are going to be equal to 8 because we have not changed elements. And that is the case for every element in the periodic table. Its atomic number is the number of protons. That's what makes it unique, and that's what makes it that specific element. Next, we're going to have neutrons. Again, we're going to use our formula. We're going to take our total mass, subtract it from our number of protons. 22 minus 8 is going to be equal to 14. So we have 14 neutrons. And then again, electrons, we have a neutral species. So our number of electrons has to match our number of protons because again, our protons are positively charged, our electrons are negatively charged, and we have a neutral atom. So that will be 8. Now let's do an example where we have a charged species and how we'll calculate for those electrons. So let's stick with oxygen. Again, 8. Let's make this 28. So protons, again, we stick with the same element each time. So our number of protons is still going to be equal to 8. Number of neutrons, let's use our formula where we're going to subtract our weight from our atomic number. So we're going to have 28 minus 8, which is equal to 20 neutrons. And now, let's say that this has a -2 charge on this atom. So we're going to use the fact of, we know that our protons and our electrons each have their charge, protons being positive and electrons being negative. Now to count this number, we know that since it is a negative number, there has to be more electrons than there are protons, simply because, again, that negative charge on our electrons. So an easy way to do this is we'll use our atomic number again, and we will subtract our charge. So we're going to do minus a -2. That is the same as if we were saying 8 plus 2, which is equal to 10. So in this case, we have 10 electrons. Let's do one more example. Again, let's use our oxygen. It's going to be 8. Let's say that it's +1, and let's say this is 18. So our protons, again, we haven't shifted away from oxygen, so it continues to be 8. Our neutrons, we're going to use our formula of 18 minus 8, which is equal to 10. And now let's use our electrons. So in this case, we have a positive. In our negative example, we ended up with more electrons than protons. So in this case, we have to have more protons than electrons. So let's again use our math. So we're going to use our 8, our atomic number. We're going to subtract the charge, which is a +1. This is the same as if we said 8 minus 1, which is equal to 7. So in this case, we have 7 electrons.